Welcome back. So we're finally ready to start coding in Unreal Engine, which means we need to create our first class. Now we've learned about the Unreal Engine class hierarchy. So what class should we create for our first class? Well, since we know that everything here in our world is derived from actor, an actor would be a great first class to create. So that's what we're going to do. Now our project is a blueprint project, but any blueprint project can be converted into a C++ project by creating our first class. So let's go up to the top bar here and click on Tools, and just under Programming, we see New C++ Class. And if we click on that, we're presented with a class creation menu. And this is one of the benefits of using Unreal Engine for our games. Every time we create a new C++ class, we have the option to create a class automatically derived from one of the engine classes. Now, we could create a class derived from nothing. That's what this first option here is. We would create an empty C++ class. Now, not completely empty. The class would automatically have a default constructor and destructor, but we also have the option to choose one of the engine classes. Now, scrolling down, we can see some of the most common classes that we would derive from in Unreal Engine, but Unreal Engine has many more classes than this, and we can see them by clicking on All Classes, and we can even search for them. But for now, we're going to stick to the common classes. And perhaps the most common are the top three here: character, pawn, and actor. And if we hover over them, we get quite a lot of information in the pop-up tooltip. Hovering over actor, it says actor is the base class for an object that can be placed or spawned in a level. And then we get lots of examples of functions that the actor class inherits. So throughout your learning journey of Unreal Engine, you may take a look at this pop-up tooltip whenever you create an actor and see how many of these functions you become familiar with over the years. Right now, we're just interested in simply creating an actor. So if we select actor and click next, then we're prompted to provide some information. Now, just under the path, it's showing us that the header and the source file will go here in source / and there's our header and there's our CPP file. Now, if we'd like, we can put this in its own folder so that we can organize classes into folders and keep our project organized. For example, we can place this in items, and we can call this class item. So this would be a basic item class. Now, in addition, we have the class type, and we can choose public or private. If we choose private, then you'll see that we'll have an items folder in a new folder called private. And if we select public, we'll see that the CPP file will be in the private folder. It'll be in private items, and the H file will be in public items. So this is a good way to separate our header files and our source files into public and private folders. And this is something you'll see more commonly. So that's what we'll do. So we can click Create Class. Now, I know I recommended that you use map mode for your scroll bar, and that's going to be really useful for you. But in my case, I'm going to disable it just to have more room so you can see more of what I'm doing throughout this course. So to disable it, I'm going to go to Tools, Options, and scroll down to Text Editor and expand all languages and hit scroll bars. And I'm going to use bar mode for vertical scroll bar and click OK. Now I just have the bar. So that will be less in the way so you can see more of what I'm doing. And you'll see that I have a larger font, and that's so that you can see the code better on your screen. So I have the editor open again. And of course, I can't see my landscape because by default, the cells are not all loaded. If I want to see the cells, either all of them or just the cells around where I see where I am in the minimap, and I can click and drag to highlight the cells around me and right-click and select Load Selected Cells. And that'll load those cells. There's no need to load the entire open world, but we could if we wanted to. But now we can see where we are in the map. So now that we've created our first C++ class, let's hit Control Space to bring up the content drawer. and we'll see something new here. Aside from the content folder, which I'm going to collapse, I now have a C++ classes folder. And if I expand it, here's slash, and if I expand that, here's the public folder. And in public, we have items. And if I click on that, I now see something here. And if I hover over it, we see that it's called item, and it's a C++ class. And the tooltip here has some information, the bottom 3 lines of which I'm going to point out. We see parent class is actor, module name is slash. Remember, our game project is a module in our Visual Studio solution, and the module relative path is public items item.h. And we can always open up this C++ class by double-clicking it, and that's going to launch Visual Studio open to this class. But we don't need to do that because we already have Visual Studio open. Now, I'd like you to take a look at the slash module and expand its dropdown. And we'll see that we have some folders and files already. There's the blackalder.ping file. This popped up as soon as we added that blackalder asset pack. But we have the source file, and if we expand that, we have some build files. These are .cs files. These control what modules are included in our project by default. We don't need to mess with those. And if we expand slash, we see that we have an overall build file for our project. We don't need to mess with that. And we have slash.h and slash.cpp. We didn't create these files. These were created by default for our project, and they're basically empty. You'll see that we have an include here for core minimal. This contains a lot of basic stuff used in our project. And we have slash.cpp, which has some boilerplate code that we don't need to worry about for now. I just want to show you that these files are here. But what I really wanted to see are the public and private files. If we expand both of these, they both have items folders. And opening the items folders, we see item.h in the public and item.cpp in the private. And as we can see, they're open here. We have item.h and item.cpp. So let's take a look at item.h for a moment. I'm going to make some room here by dragging these both down, and we'll take a look at what our item class has by default thanks to our class creation wizard. We have pragma once, and as you may know, this is something that ensures that if we ever include item.h in some other file, we'll only include it once in case we accidentally try to include it more than once. And there's that core minimal, which contains, well, core minimal functionality that actors typically need. Now, our class A item inherits from the A actor class. And in order to inherit from actor, we have to include the actor header file. And actor is in game framework. So by default, we have this include here so we can inherit from actor. If we say remove this line, then the compiler would not recognize the actor type. So we do need to include a header file for a class type if we want to inherit from it. Now, normally in regular C++, you would typically see class A item, public A actor. So what's this slash API? Well, if we hover over it, we see that it expands to declspec DLL export. This just makes it so that this type can be used from a DLL or dynamically linked library. It's just automatically included by Unreal Engine, and as soon as we created our slash project, this slash API macro was created. So we won't be messing with that. That's going to be there whenever we create a new class. Now we do see that we have the item.generated.h file. This is auto-generated for us, and it contains all of the code needed to have our class participate in the reflection system. And that's why we have our uClass macro here. So our item class is capable of participating in Unreal Engine's reflection system. And the generated body macro is here for that same reason. So whenever we compile, this generated body macro will be replaced with some of the code in that generated.h file, giving this actor more capabilities. So think of this as like a regular C++ class beefed up with extra functionality, allowing this class to participate in a bunch of under-the-hood stuff that Unreal Engine does for us to link this class with the engine's reflection system, and we get lots of benefits from that, including being able to make a blueprint out of this class and expose properties to blueprints and so on. And we'll get to all that stuff in time. Okay, so after taking a look at all that boilerplate code, the main part of our class is down here, and you'll see that we have, by default, a public section and a constructor. And Unreal Engine is kind enough to tell us that a constructor sets default values for this actor's properties. That's something that we should already know about constructors, but it's there for us. And then we have a protected section with a virtual void begin play override. So this suggests that begin play is a virtual function inherited from the actor class, and we're overriding it. And the comment says called when the game starts or when spawned. So we have a handy function that will be called for this actor at the beginning of the game, or if we spawned one of these mid-game. And in the bottom public section, we have a function called tick, which takes a float called delta time. And this is also a virtual override. And the comment says that this is called every frame. So the tick function will be called many times per second. Every time the image on the screen in our game updates, which can be 60 times per second for older machines and as fast as 120 times per second for newer machines. So tick is something that's called very, very rapidly. And if we go to item.cpp, we'll see that our constructor is defined, and so is begin play and tick. Now, Unreal Engine has this handy thing called super. And if we ever call super with the double colons here, that's the scope resolution operator, followed by the name of a function, this means that we're calling the parent version of the function. So our item class inherits from actor, right? Well, if we call super begin play, we're calling the actor version of this function. And that's because the actor version may implement some functionality in begin play that we need, that we may not be aware of. So when overriding a virtual inherited function from actor, it's a good idea to call super just in case actor implements anything at the beginning of the game in the actor begin play function. And the same goes for tick, since this is a virtual override as well. And again, we have these comments that tell us what these functions do. Now, the item constructor has this primary actor tick dot b can ever tick equals true. And we see the comment says set this actor to call tick every frame. You can turn this off to improve performance if you don't need it. So if we don't need this actor to perform some functionality every single frame with the tick function, we could set this to false and it would never tick. And if we hover over primary actor tick, we can see its type. Its type is fActor tick function, and this is a struct which contains the variable b can ever tick. So actors have this variable called primary actor tick, which has the type fActor tick function, and this struct has this boolean, and that's where we go to enable or disable ticking for an actor. So not all variables are just declared on the actor class itself. The engine defines some of these structs to sort of act as packages of these variables, and that way the actor class is not overwhelmed with variables and functions. So this is a way that Unreal Engine uses to keep the class organized into categories of behavior. So we've created our first C++ class, and I'd like us to get some experience with begin play and with tick, but we'll do that soon enough. For now, let's just organize this class to how we want it. You may think it's strange having two public sections, but the truth is we don't have to have two public sections. We could move the tick function up to the public section up here at the top. I typically like to do that. So what I'm going to do is highlight this line and click and drag it up to move that function declaration up to this top public section. And since we already know that a constructor can be used to set default values for a class's properties, I'm going to remove that comment. And now that we understand that begin play is called when the game starts or when an actor is spawned, I'm going to remove that comment as well. Feel free to leave it if you like, but I'm going to remove it. And we don't have anything in this bottom public section, so we can remove that as well. And now our class looks a bit more compact. We just have a public and a protected section. Now, in our item.cpp file, we can also get rid of these comments to sort of decrowd the CPP file, since we now understand what these lines of code do. So again, you can leave those as a reminder if you like, but I'm going to remove them. And now it looks a lot cleaner. Okay, so that looks great. So we have our first C++ class. Now we don't know what to do with it yet, but in the next lecture, we're going to make use of begin play and test it out and make sure that we can prove that it's being called at the beginning of the game. So we'll do that next. I'll see you soon.